Hello, my name is Cherry Machado and thank you for the question. If I understand correctly, you're asking me to describe a recursive function that can take any valid binary tree and determine if it meets the specific ordering requirements of a binary search tree. To begin, a binary search tree, or BST, has a crucial property. For any given node, all values in its left subtree must be less than the node's own value, and all values in its right subtree must be greater than it. A common mistake is to only check a node's immediate children, but this rule must hold true for all descendants, which is why recursion is a perfect fit. My approach would be to create a recursive helper function. This function would not only accept a node to check, but also a minimum and maximum value. These min and max parameters define the valid range of values that the current node and all of its children must fall within. Here is how the recursive logic would work. First, the base case. If the node we are checking is null, we've reached the end of a branch. An empty tree is technically a valid BST, so in this case, the function would simply return true. Second, the validation step. For the current node, the function would immediately check if its value is within the min and max range. If the node's value is less than or equal to the min bound or greater than or equal to the max bound, it violates the BST property. The function would immediately stop and return false. Finally, the recursive calls. If the node's value is valid, the function must then verify that its subtrees are also valid. It would do this by making two recursive calls. Number one, it would call itself on the left child. For this call, the min boundary stays the same, but the max boundary is updated to be the current node's value. This ensures all nodes to the left are smaller. Number two, it would then call itself on the right child. Here, the max boundary stays the same, but the min boundary is updated to be the current node's value, ensuring all nodes to the right are larger. The function would only return true if the current node is valid and both of these recursive calls also return true. To start the entire process, a primary public function would call this recursive helper on the root of the tree, with the initial range set from negative infinite to positive infinite. The range-based recursive strategy is robust because it correctly enforces the global ordering rule across the entire tree, not just at a local level. So thank you very much.